Well, good day again. We are working on section 4.5, which is about systems of linear inequalities. All right. So we've done systems of linear equations, and we're going to now use our skills we have from that to help us solve, linear inequalities, inequations. That'll work too. Sorry about that. I said equations and wrote the wrong thing. But systems of linear inequalities. Qualities. There we go. All right. So now let's get going and take a look at what these problems look like. Okay, here's a system of linear inequalities. You actually have two equations. You could have more equations if you want, but most of the ones that we do have two equations with two unknowns. And what we want to do, if you'll remember back in the last chapter, we graphed an inequality. So we would take x plus y is greater than 4, all right? And let me go ahead and make this graph. We would take that and we would graph it, okay? And super easy to do. We would make an XY chart and we could find the intercepts here. Pretty simple. If you plug in 0 for x, you get y equals 4. And if you plug in 0 for y, you get x equals 4. So this one works out fairly fast where you can get the line. Now, it's greater than or equal, so we would graph a solid line. And then what we would do is we would shade on whichever side of the line. Now, in general, I pick a point on the x-axis or the y-axis, or I pick the origin if I can, as long as it's not on the line. In this case, the origin isn't on the line, so I'm going to check. Is 0 plus 0, so I picked the origin, is 0 plus 0 greater than or equal to 4? And that is false. Since it is false, I shade the other side. Okay? So that's how this works. So I would shade the other side. And that's what I'm doing right here. Just shading it. And that's how we did it with one inequality. Well, if you do two inequalities, you got to graph the other one as well. So let's go back and let's graph the other one. All right. So we have x minus y is less than or equal to 2. So xy chart, if I let x equal 0, I get negative y equals 2, which is y equals negative 2. And if I let y be 0, I get x equals 2. So 2, 0, so I can graph that. So this is 0, negative 2, and 2, 0. It is less than or equal. Since it's equal, that means I graph a solid line. And then I shade for this line. So again, 0, 0 is not on the line, so I'm going to use that to check. And when I check 0, 0, I get 0 minus 0 is less than or equal to 2. That is true. That means I shade that side of the line. So I'm going to use a different color here to shade. Okay. And when I shade that part of the line, I'm shading this side. And you see that what happens is you get some overlap in this area, some overlap. So that is the overlapped area, that is the solution. Okay? That's the solution to the equation. And so I would actually, I'm doing this electronically, so I can erase these portions. I can erase these portions here. They're not part of the solution because it was only one line, but this area where they overlapped is the solution. Now, what I usually do when I graph lines like this, I'll have lines and I'll do sort of a crosshatch like this, and then where they overlap is the solution, and that's the only place I'll highlight really darkly. So my graphs would tend to look like that. Okay? And yours might too. Now, what's nice about this is you can check this easily with Desmos. You can check your work easily. So do the whole assignment, then go back and check your work. And I'm going to show you how right now. All right. So here's Desmos. Okay. And I'm going to show we get the same graph. So we're going to go x plus y is greater than or equal to 4. Right? See how they shaded that? They did red, I did yellow. I should have did the same color. And then the next one is x minus y is less than or equal to 2. And you can see that the overlap is this area here, the purple area, and the blue and red are not the area. And so the overlap is the solution. Okay, so with Desmos, it's really quite easy to check the graph. And you can see it looks exactly like our graph. All right, that's the main strategy. So you have to graph both of these. Let's just do one more example for kicks. As I've said before, remember you can go to mathbits.com and you can print out graph papers, which will make your graphs much more accurate, and I would recommend that. Or you can go to incompetech.com as well and print out graph papers. Both of those pages are good for that. All right, let's do this. I'm going to first graph x minus 2y equals 4, that line, which is x and y. I'm doing the intercept, so I get negative 2y equals 4. So y equals 4 divided by negative 2, or negative 2. And then I do y is 0, and I get x equals 4. So 4. So 0, negative 2, and 4, 0. So I plot that. Let's do this in red. All right. Now, notice this was greater than 4. So when I draw this line, it is a dotted line, okay? Dotted line. And that's one thing you have to remember. A number of papers before, when we were doing inequalities, I did not see that on student work. All right, so 2x plus y is greater than or equal to 6, so that's a solid line, okay? And I'm going to find the intercepts. When x is 0, I can see y is 6. And when y is 0, then I get 2x equals 6, or x equals 3. So 0, negative 6, down here, all right? 0, negative 6, and then 3, 0, which is right here. And this is a solid line. So there we go. So now what we've done is we've graphed the two lines. So I'm going to check the red line for which side to shade, okay? And so 0, 0 is not on there. So I'll check 0, 0 in the equation. And I get 0 minus 0 is greater than 4. That is false. So I'm going to shade below the red line. I'll just write that here, below red. All right, so it would look like this. I'm going to just crosshatch like I do on my paper, below the red line, okay? And then the blue line, 0, 0 is not on the blue line either. So I can check that, and I get 0 plus 0 is greater than or equal to 6. and that is also false. So therefore, I shade below the blue line as well. That's the opposite side. So I'll say below the blue or kind of on the right. And here's the crosshatch for the blue line. And as you can see, they overlap in this area. So now I'm going to go and shade that area, because that's where the solution is, right there. Okay? So all of these all the points in this area will actually satisfy the inequality, both of them at the same time, which is fairly cool. All right? So that's how you do this problem. Remember solid dotted lines, and then pick a point to check. And if it's true, you shade on the side of the point. If it's false, you shade on the opposite side of the line. Okay? Now let's look at some of the applications. One application is you could have more inequalities than just two. And so in this case, we have three. And if you go to graph this, you get one line here. And then when you shade that, you end up shading on this side. And then the next one, that line is here. And these are all solid. And for shading that one, you end up shading on this side. And then the third line, the x greater than or equal to 4, is over here. And that's just a vertical line, and greater than 4 is over here. And so you got to look for the place where all three cross. And that's maybe the point on this one, where all three areas cross, and that is here when you do the lines. Now I did that fast. I knew how to graph these lines right away, so I just graphed them. And so I graphed them all really fast, and I knew which sides to shade pretty quickly. But what I wanted to mostly show you is that, you know, the more lines you have, the more cross-hatching you have to look for, and to find the area where all three equations are satisfied at the same time. Okay? And so it would be over here in the highlighted yellow. That's one thing. So the other thing, and I think this application's pretty cool, it's actually like a health application. And what they do is they give you some equations. Okay, and where x represents height, and y represents weight, and these equations model a healthy weight region for your height and weight. So when you draw these equations, whatever they look like, I don't know what they look like right now, and you shade them, that might be, this would be a healthy weight and height area, or maybe this would be, or this would be over here. So one of these areas kind of indicates healthy weight and height. All right. And so one of the things you want to do is you want to be able to graph these, and then you can answer questions on that. So somebody could say, oh, would a particular point on a graph, so they might pick a point like A, and that point might be like 66, 160. So what that is that would be 5'6", 66 inches, and 160 pounds. Would this be considered a healthy weight? And so what you'd be looking at is if it was a healthy weight for the height, it would be in the range of the lines. If it was not, the point would show up outside, either as being too light or being as too heavy. And that's kind of how they do that in this case. So the key thing is you just have to answer the graph and then answer the questions based on the graph that you have. All right? That's all I have for you on this lesson. See you later. Bye.